Hello everyone, so this is going to be the second video of gRPC playlist, and in this video we are going to understand the intuition how the gRPC is working internally and how we are going to make it. So without wasting any time, let's get started and study. So first of all, let's understand this figure. In this figure, I made a small server here that is a React application which is having two functions, function 1 and function 2, and there is a backend server is created in which there is an API name /abc and that is returning a string. That server is written in Java. Now what is happening, what I'm doing right now, like suppose like there is a React website in which if we press a single button, this /abc website is getting called to our backend server. So we are using Axios to call backend API. You can use fetch also in our React. So let's not go there. So simply we are just hitting an API to our backend server, and our backend server is going to respond back to this particular API. So we are sending a request and we are getting back a request. This is how our communication is happening with the help of our REST framework when we are using /abc API. Now let's understand, if you have to do all this thing in a gRPC, what is happening? So basically, if we have to go to a code side in the React, what we are going to do, in this function 1, it is going to be written something like that. Is like if this is a function 1, we are going to directly call our API. Instead of an API, we are directly call this function 1 of Java. So we will say channel dot function 1. Function 1. So what is this channel? And we are not using this API this time. Previously, the communication is happening with the help of an API. We make an endpoint /abc. This time we make a particular channel, and in that channel what we are doing, we are directly calling the function of a different server. This is something very different. In the function 1, what we are doing, we created this channel. This channel is, let's say this Java program is working on any IP on any port, let's say 10.0.02 and on the port 9090. So we will open a channel from React to our backend server, and previously what we are hitting the endpoint /abc on that particular server. This time we are connect with that particular channel, and now what is happening, we will directly able to call a function of a Java language in our React application. So this is not happening in an API. We are directly calling a function of a Java in a React application. This is very amazing. So this is against this channel.function is going to return a string because this is returning a string, and all this transfer is going to happen in binary. So now let's understand how it works, how it is all happening. So this time I created a gRPC server in Go. You can create it in any language, doesn't matter. This time there is one more server in a server named Ruby, and there is one more server in Java. So suppose like in the Ruby language, I want to call a function of Go language. So suppose there are 3 microservices written in different languages, Ruby, Go and Java. In a gRPC, these both servers internally are going to connect on some port 10.9090. This will act as a client. This Ruby server will act as a client for this Go server, and now instead of an API, this Ruby server will get a power to directly call the function of the Go server. This makes gRPC very powerful. So Ruby will send a Proto request. So what are these protos we are going to see, and we are going to return a Proto response. And when we are going to return this Proto response, I mentioned there is a word gRPC stubs. So what are these gRPC stubs? So gRPC stubs are going to convert this Proto files into a Ruby file. So what is this happening? Now what happens right now, suppose the request is saying that I need a data in a form of an ID. Okay, so ID is going to be like when you are writing a code in a Ruby language, so what will happen? The code is going to convert in a Proto format. You can just simply say a binary format. It will reach to Go. Go will understand that binary with the help of the gRPC stub of Go. Now again, when the gRPC stub of Go understand that thing, it will return a response. Again, the gRPC stub of Ruby will convert that binary into a Ruby format, and so that Ruby can understand it. Ruby language can understand it. This is how the stubs are involved in this whole process. So this is a simple proto file that I made for you. In this is a syntax that we are using a Proto 3. We are sending a message hello request. In this hello request, you can see we are sending just an ID. You can also send a string message. In the response, you are saying hello response ID is going to be 2 or ID is going to be 1, and again string response equals to anything. You can add more fields as well. Now there is a service chat. Okay, again I made a service chat that will say start chatting. It will take a hello request and returns hello response. So if we have this code, so this proto file is going to present in all the 3 servers. So let's understand this. This is our Go server. No, let me just make the Go server here first of all. This is a Go server. This is our Ruby server, and this is our Java server. So we have this proto file. So now we will use proc. Proc is a proto file compiler that will help you to convert this whole proto file into Go stub. Same, we will use proc here. Again, it is a compiler. The compiler, it will help you to convert into this proto file into a Ruby stub, and same Java here. We'll use again proc to convert this proto into Java. Now what will happen? Here what you will do, when you will get this stub, you will override this particular method of start chatting. Here start chatting is written in a format like it's just a function definition. But now what is going to happen? You are going to change, you will write the complete code, like you want to take the request, you want to return. Okay, so you write this function, let's say start chatting. You define that function in our Golang. Now what has happened? Our server is ready. Okay, so this is our server is completely ready. If someone calls the function of this start chatting, it will take the request, it will return the response. We have done that. Our server is ready. Now this Ruby wants to call this particular API or this particular function start chatting. In the case of an API, you will just make an API of the start chatting function and you will do that. But we are using a gRPC, so this Ruby will make a connection with our Go on a port, let's say 9090, because this Go server is working on any port like 9090 on particular IP. This Java can also make a connection. These are just clients. Okay, so they made our connection that I named that particular connection as the name of a channel. Here I mentioned the name channel. After that, what will happen when we make this connection? These Javas and this Ruby client can directly call this start chatting function on this network 9090. This is how internally things are going to happen. That they are going to send the request. So in the Ruby, you can just make the button will be pressed in any UI. Then internally you can just go to the Ruby and there will be a function. And with the help of that stub, you will just say call start chatting function on this particular channel. The request will directly come into a binary format to our Go server, and then they will return the response. Same with Java as well. So this is how internally our gRPC is working. We are not dealing with APIs, we are directly calling the functions over the network. This is how gRPC changes everything. So thank you for watching me, and in the next video, we will understand the use cases, where to use gRPC, where to use REST and everything. And after that, we will just move to our coding part. Thank you for watching me, and bye bye.